Hello and welcome to today's lesson on function inverses. We're going to be covering topics under the standard 2.1e in Algebra 2, and then also questions under the Study Island lesson function inverses. So if you need help with either of those things, this is the place that you want to be. The main key to today's lesson is knowing how to solve an equation for y. So we're going to be rearranging the equations, and then if you can solve for y, then you're going to get this down pretty easy. And just remember that you should be taking notes as we're going through these lessons. Notes are a great thing to have to refer back to and to study from. And then you also are free to pause and rewind if I go too fast so you can get caught back up. And then remember, you can always pause at the beginning of a question, work the problem out yourself, and then use the video to check yourself, and that way you can see how well you're doing on your own. So I'm so glad that you're here, and let's go ahead and take some notes. So to find an inverse of a function, we're going to have to follow the following steps. So if it's in function notation, we're going to change the f of x to y. And then you're going to flip the x and the y. So the x's become y's and the y's become x's. And then you're going to have to resolve for y. And then the symbol we use for inverse is f to the negative 1 of x. So in order to put it in proper notation, we're going to change the y to that. So this first problem here is they want to know which graph is represented by the inverse. Well, first we're going to have to find the inverse. So we're going to change the f of x to y is our first step. And then our second step is we're going to change the x's to y's and the y's to x's. So this is going to be x equals y cubed. And now I have to solve for y. So I'm going to take the cube root of both sides, and that's going to undo the cube on the y. And so here, this is going to be the cubed root of x is equal to, and these roots in the cube cancel, y. And now y is by itself, so this is the inverse of our original function, is the cube root of x. And so which graph here represents the cube root of x? That's going to be w. And if you were ever unsure of that, you could create a table and test some points. Or you could use your graphing calculator to graph the cube root of x and see which one matches. So now we have the function 2 plus the square root of x, and then it's telling you that we can only have a domain where x is greater than or equal to 0. So that means that when we flip the inverse, that domain still holds true, so we're only going to have the part of the graph that's greater or equal to 0. So here, the first thing we have to do is find the actual inverse. So I'm going to change f of x to y, and then I'm going to change the x's to y's and the y's to x's. That's my second step. And now I have to solve for y. So my first step to solve for y is to subtract 2 from both sides, and I'm going to get x minus 2 equals, those 2's cancel, the square root of y. Well, the opposite of a square root is squaring. So I'm going to square both sides. And here the roots in the square cancel. So I'm left with just y on the right. And then I have the x minus 2 squared. And so now it's a quadratic graph. So the quadratic graph shows that's a U-shaped graph. And because that U-shaped graph has a minus 2 here in the parentheses, that means it's going to be shifted to the right 2 units. So that means this vertex is going to be at positive 2. So the only graph here that has a vertex at positive 2 is y. And remember, this here said you're only going to have half of the u because you started with just the values greater or equal to 0. So that just tells, that domain told us we're going to have half of the u. So here it's graph y, which makes my answer A. Once again, we're asked to identify the graph of an inverse. So we're going to want to first identify or find that inverse. So I'm going to change f of x to y. And then I'm going to change my x's to y's and my y's to x's. And so now I have to solve for y, but y is an exponent. So we're going to have to use what's called a logarithm to get y out of being an exponent and by itself. So we're going to have to take the logarithm of base 2 of both sides. And it's base 2 because the base here in this exponent was 2. And if you need more help with those, you can look at the logarithm video that's further down the list. And so log base 2 of 2 to the y. And so here, this doesn't simplify at all. It's still log 2x. But here, the whole reason we did this is because all of this cancels out and we're left with just y. So now we're looking for the graph where y equals the log base 2 of x. And so a log graph, we know, starts out vertical and then tapers off and looks more horizontal at the end, or starts instead of, and increases less. And so the only one that has that shape is graph Z. So that makes our final answer A. All right, so once again, we're identifying the graph of an inverse. So we're going to want to go ahead and calculate that inverse. We're going to have y equals the square root of x plus 2. So I did that first step of changing f of x to y. And now I'm going to change the x's to y's and the y's to x's. And then I just have to solve for y. Well, y is underneath a square root. So to undo the square root, I'm going to square both sides. And so I have x squared equals, and here the root and the square cancel, and I'm left with just y plus 2. And then I need to subtract 2 from both sides. And then, so I have x squared minus 2 equals y, because those 2's canceled out. And so y is by itself, so now I'm looking for the graph where x squared minus 2. Well, I know that an x squared graph, a quadratic graph, is U-shaped. And I know that this minus 2 here outside of the parentheses is going to shift it down 2 units from 0. So the only one that has a U shape where it's shifted down to -2 is Z. And the reason it only has half is because it started with a square root that had this domain x is greater than or equal to -2. So that tells us that it's because it started with a domain, we're only going to have half of our u. And so Z is our graph, and so that makes our final answer B. The other type of question you're going to see in this section is ones where they give you two functions and they want to know, are these inverses of each other? Well, in order to be inverses of each other, then if you take the composition of f of g of x and then do it the other way, g of f of x, both of those should reduce to x. And so then you know it's an inverse function. So that means if it's an inverse, then it's going to be an inverse because of this. So here it says it is an inverse because of this. That could be an answer. And then the opposite, if it's not an inverse, it's because it doesn't equal that. So this A and B choice that they give will never be answers. They don't make sense. Automatically that those are wrong. So you can automatically cross out the ones that have the not with the equals and the is with the non-equals. Because you need the not with the not equals and the is with the equals. So we know it has to be C or D right off the bat. So you could go ahead and calculate the composition both ways and see if they both equal x. Or you could just take that first function and calculate the inverse and see if it matches the second one. So that first f of x, I'm going to change it to y, and it's going to equal 2x minus 8. And then I'm going to change my y's to x's and my x's to y's. And then I solve for y. So same steps as before. So I'm going to add 8 to both sides. So I end up with x plus 8 on the left. These 8's cancel, and I have 2y on the right. And then I'm going to have to divide every term by 2. And so remember, there's this invisible 1 here in front of x, so that's really just 1/2 x because I can't reduce that anymore. 8 divided by 2 is 4, and 2 divided by 2 is 1, so those cancel out, and I'm left with just y. And here, so this is equal to 1/2 x plus 4, and this was also 1/2 x plus 4, so they are inverses of each other, so D is going to be your answer. All right, so same type of problem. So I can automatically cross out A, because that has the not with the equals, so that will never be my answer. And C, because that has the R inverses with the non-equals, and that will never be an answer. So I have it now down to 50-50. So now I'm going to go ahead and calculate the inverse of the top equation. Or you could do the second one too, as long as you keep it straight. And so I'm changing that f of x to y. And then my next step is going to be to change the x's to y's and the y's to x's. So I have this equation that I now need to solve for y. So when I'm trying to solve for a variable and it's in a fraction, I like to set it up as a proportion. So I'm going to put a 1 over x, and then I'm going to cross multiply. So I'm going to have x times that entire bottom, y minus 7, equals 14 times 1 is 14. Well, now I can divide both sides by x, and these x's cancel, and I'm left with y minus 7 equals 14 over x. And then I want to add 7 to both sides. These 7's here are going to cancel, and I'm just left with y equals, and it's just going to be that 14 over x plus 7. And so this is the inverse. Up here, it had a plus 2 instead of a plus 7. These aren't the same, so they are not inverses of each other. So that means my answer is going to be D. So once again, they're asking if these two functions are inverses. And so right off the bat, I can get rid of C because it has the not part with the equals. And I can get rid of D because it has the R inverses with the not equals. Those will never be choices. So now I'm just going to calculate the inverse of f of x and see if it matches g of x. So I'm going to switch those x's and those y's. And so now I'm going to subtract 6 from both sides. And I'm left with x minus 6 equals 1 over y. And so to go ahead and get that y out of the denominator, I'm going to go ahead and put a 1 underneath here and then treat it like a proportion and cross multiply. So I'm going to have y times that entire x minus 6, so I need to put that in parentheses, equals 1. And now, because that x minus 6 and the y are being multiplied, I can divide both sides by that entire expression, x minus 6. And those cancel. And I'm left with y equals 1 over x minus 6. Well, here, the x minus 6 are separated. X is in the denominator, minus 6 is not. Here, that whole expression is in the denominator, so they don't match. So it's going to be no, they are not inverses, letter A. Thank you for joining us today, and I hope you learned something new.